So, Derek, thank you very much for taking the time to talk to me. For the people who are going to be watching this, I'm sure it's going to be of great value to them. The work you've been doing is, I think, very interesting. But I thought I'd start by just asking you about the project that you've been involved in. So, this is a very interesting project, applying digital technologies in the construction industry. And I thought I'd ask you just to describe the project and the impact that it's intended to have on the industry.
Sounds good. So it would be a little bit, I'd be remiss not to talk about the scale of the company I work for before diving into. I wouldn't even necessarily call this a project. It's a group of projects, so to speak. So more of a program, but the program that I'm running is essentially BIM. So building information, either modeling or management, depending on who you're talking to or about it. I defer to the terminology of building information management because really that's the core of what we're trying to do as opposed to doing the modeling. We want to extract and use the information out of the model on the downstream to essentially do construction better. Now, the company I work for is Mattamy Homes Canada, and we do have our US sister company as well, but my focus is on the Canadian side, and I would say that our yearly production of homes right now across Canada sits at around 4,000 homes a year, give or take. So the size of our production is certainly nothing to be scoffed at. And in that sense, the project that, or the program that we are running right now, if it were to be launched across all of our product lines and all of Mattamy Homes' production in Canada, there would be a sizable impact on the Canadian construction industry as a whole, and the use of technology within the industry, simply just by our production and level of influence.
Excellent. And so, can you talk about what the project is?
Yeah. So BIM itself is essentially virtual construction. So what we want to be able to do is, in the past, and this is probably a good way to talk about it. In the past, or even right now, the traditional method of home building production has been very much 2D CAD drawing based. And that's absolutely fine. To be very frank with you, that process and even CAD as an innovation on top of, like drafting boards in the past is from the use of digital technology and the ease of transferability and modification if you make a line drawing wrong and so on and so forth. But the entire process is still largely similar or practically the same over the past however long it's been since we started using drafting tools. So I would say probably 100 years or perhaps more. Now, BIM is not the same thing. And I think like my earlier clarification with BIM being an information management tool, hopefully sort of sets the stage for this part of the conversation, because using BIM, it's not just drafting in 3D. And I think that's a very important clarification to throw out in the front, because this technology-enabled process, which is what I like to call it, what it strives to do is digitally construct the homes that we want to build while we're doing the design or as we're finishing up the design. So prior to construction phase, the home should be not only designed from an architectural perspective, but also coordinated for clashes, have materials modeled out such that we can grab information for material quantity takeoffs and be able to use it for specific construction troubleshooting for where materials need to be placed across a 3D model. So the 3D model itself is not just a geometry. The individual components in there, we'll call them smart components, as in if you model in a 2x4, that 2x4 in the model space will know that it's a 2x4. And if you query and ask the model to spit out the information, in theory, it should be able to spit out that that amount of information to tell you how many 2x4s are in there. And perhaps I'm using the wrong example. Let's talk about walls or windows or square footage area of brick. Obviously, the modeling detail will dictate how much information you can draw out of the model, and that certainly is something that we're working towards. And to be very frank, modeling in individual studs is not actually something that we tend to do in current day and time. Although we are starting to try to play with that, we don't know if that's entirely a necessity for this to work. However, I think I'm diving a little bit too deeply into the weeds there. The overall idea of what we're trying to launch is have a model that before we go to site, and this is how in the traditional building method it happens, and it's not like it's something that works. The way we do it is we do the design, we work everything out as much as possible in the 2D world, and you can imagine if you draw a engineered floor drawing, then you have the layout of the home, where flooring goes and where the walls are. Then you have HVAC drawings. Then you perhaps have some markups on where plumbing stacks might show up. And then you try to overlay all of them on a 2D world, even in CAD. It becomes a very big jumble of information, right? So you can use that to do as much coordination and clash resolution as you can before going to site, but you're still going to miss something invariably. And the idea is that if you have all that in 3D space, you can coordinate that long before you build. But in the traditional world, what would happen is we would go to construction and we would build the first home. As we're building it, our construction teams and our trades work together to resolve any issues that we find, any clashes that we might have missed. And, and once we resolve that, that's how we refine, number one, our construction method, number two, our material quantity counts. And as the project progresses, every house gets better and better refined. And that is typically how we do construction. And right now, the method that we're proposing right now will, in a way, eliminate that initial level of, I guess, let's call it discovery or resolution, by doing that in a digital environment.
So for the layperson like me, I would think of construction being guided by blueprints or drawings that come from a CAD system. What you're describing is a super type drawing in 3D that allows lots more information to be considered, but which also is smart to the extent that it can understand relationships between the various aspects of the construction and deal with the consequences of those relationships, which in the past often or usually wasn't done until you were under construction and people were having to solve problems at much higher cost probably, and potentially with negative consequences for the final house or whatever you're building. So this is a very important thing that you're doing in order to make house building and other construction presumably better than it is today. Now you're managing this activity, but your previous job wasn't in construction. And what you're doing with the technologies is to some extent radical. So how did your career before construction influence your ability to do what you're doing today?
Yeah, so I wouldn't say I was entirely outside of the realm of construction in my past life. So just as a brief explanation, I after I graduated from mechanical engineering in undergrad at the University of Waterloo, I did work in engineering for a couple of months before I went and worked in a logistics firm for a couple of years where I was managing supply chain work. And then from a very business based perspective, and I think that's important because of it sort of informed my career choice later on. Then I went back into the engineering world a couple of years later, and that world was EPCM, so engineering, procurement, and construction management. And that's the piece where there's still some tangible relationship to construction, but it's more from a management perspective as opposed to being closer to the actual finished product. And especially in these firms being known as consultancy firms, most of our design work and engineering work was done remotely, and that information was then transferred to site to be completed. And the types of sites that we were working on were resource projects. So you think of mines, refineries, processing plants of all sorts. And my very specific role then was as a piping engineer. So a lot of what I dealt with was stress calculations of piping systems. We did process and power piping, so ASME V31.3 and ASME V31.1 respectively. The associated design and material standards that would go along with those pipes to be specified. So piping specifications essentially. So like designing and putting that together was essentially my role. Now in that world, to relate to how I got interested in BIM in my career now, in the world that I came from previously in EPCM, I don't think they called it exactly BIM because most of this was internal to the company that I was working at the consulting firm. A lot of terminologies get thrown around, but I always thought of it as Smart 3D, where we designed out a plant, the whole plant within a 3D environment. And when I was doing engineering procurement, I'd be able to click a couple of buttons and it would spit out an Excel file essentially for me to use as the bill of materials or form the basis of my bill of materials and conduct bid evaluations and so forth. So the world of what we're defining BIM as was practically natural for me because I lived in this engineering consultancy world for so long. Now, after a couple of years in a technical position, I realized, at least for me, that and this had a lot to do with my time in business in the logistics company that I mentioned earlier on in my career. I realized that I wanted to make more impact and make more decisions from a business perspective because I felt that the potential impact and the positive impact that I could make from that seat and from that lens would be higher, at least from my personal perspective, than I could have done as a pure technical engineer. So that was when I decided to go back and do an MBA. And so I went to Ivy Business School for that. Once I came out, I went into a leadership development program that Mattamy Homes Canada happened to have hosted at the time. And the rest is history. While I was digging around or like learning from all the different rotations that I was in, I number one, I realized that the entire construction industry, the way that we perform construction isn't necessarily equal. And especially in low-rise home building, because and here's to qualify why there's the difference. In my past life, doing a refinery, I don't know, thousands of kilometers away from where my office is, you need that high level of accuracy. We're also designing pipes that are sometimes 24 or larger inches in diameter, or sometimes up to 1,000 Fahrenheit of temperature. So it's high pressure, high temperature processes that can get pretty dangerous. So having a high level of accuracy and design accuracy And you know, as an engineer, obviously, that was sort of the state of affairs that you need to be at. However, and not taking anything away from home building and residential construction, but the level of tolerances and standards for a Ontario building code completed home, at which we actually at Mattamy we exceed, where we build typically to Energy Star, if anything, but still it's not to the same level as when you do ASME B31.3 process piping. So it's two different worlds. But what I realized, and since the days of my engineering life, I understand that the technology has gotten a lot more mature, and it's also a lot more accessible at different tiers and different levels of industry. So it'll no longer cost hundreds of hundreds or thousands of dollars to procure software in order to perform all of this. So that was where I realized that there would be an opportunity for this type of work, and that's how I guess my past life has really influenced my decision to head down this path and manage at least what I feel to be a very worthwhile endeavor in this industry.
Which it seems to be. The description that you gave me earlier of what the project was going to do is certainly a fundamental change to the way that things were done in the past. You've mentioned to me before that an attempt was made to introduce digital technologies in construction that was unsuccessful. So can you tell me about that attempt and perhaps what you learned from it?
So this wasn't a Mattamy or a my past life attempt in that sense, but it was certainly something that I kept a very, very close eye on, because this also partially influenced my enthusiasm at the time for diving down this path a bit. Um, it's on a company called Katerra, Katerra, that you may or may not have heard of. But essentially, the long story short is in 2018, which is approximately when I started my role at Mattamy Homes, this company was founded. I think it was also founded in 2018. It might have been a little bit earlier, but somewhere along like that timeline. And when I read up about this company, I was extremely impressed, because they took the philosophy of mass production, the production line, and a lot of tech-based knowledge. So and their funding came from SoftBank, I believe. They had a CEO who had been in the been through the ringer in Silicon Valley. I believe he might have been a previous executive at Tesla, and like, all in all, it just sounded like an extremely promising firm that was out to disrupt the residential home building industry. What I did see, and like most of this is obviously anecdotal and based on information that I found or had read in the news or I kept track of on the internet, but this extremely promising firm took a lot of steps, like, and I feel like as a post-mortem, let's call it, when I read about this firm, it has unfortunately failed. I think it was over this past summer, so perhaps like May or June of 2021, where they closed their doors. And so, as a post-mortem, reading up on what might have caused the failure, or where they had invested, what moves they had made. What I read was, in large part, was they were aggressively vertically integrating. They thought that as long as they can dominate the whole supply chain and the value chain, that change, let's call it this way, that change would be simple and easy. And they found out the extremely hard way that it is not necessarily the case. And I think the number one reason is that a house is not a car. It's also not an iPhone. It's also not a, you know, whatever a lot of people might think of from whenever they think of mass production. It's consumer electronic items, or, you know, a vehicle, right? And, you know, running a home, the method of production of a home entirely through a productionized basis isn't, you know, without actually consulting and understanding how the current industry works, makes for a very, very difficult case of, you know, trying to change this industry. There's, and at least from my perspective, there's a reason why over this period of time, let's say, and I've seen a couple of memes in the past where they showcase, you know, 1900s vehicle production versus 2000s vehicle production, and you see, you know, a bunch of folks on an assembly line, like standing right next to each other doing a car. In 2000, you know, it's all robots in in an automated production line, whereas the home building 1900s and 2000s looks largely the same. And so I believe that there's a reason, and a somewhat good reason for that, is that the current level of technology that's used to build a home has been sufficient based on the current level of production and the speed of production and the available talent, let's call it, you know, our skilled trades. And so that's what makes this change, or any change in this industry, a somewhat difficult proposition. And the reason I talk about this, and like one of the biggest learnings about Katerra's failure, is that I take it to heart that I'm not saying, and I never will say, that the current construction method of low-rise homes is, you know, doesn't work. It obviously works, right? We've been doing it for literally 100 years. So, you know, what I do want to be able to do is to make the home building experience for our trades, for our builders, for everybody involved, a more efficient experience, a better, you know, a more structured experience, and where we can continually improve until the point and perhaps someday we will get to largely automated, you know, panel production. And actually, in some cases, we're already there, but it's not a flick of a switch. And I think that mentality is what caused Katerra's downfall, at least from my perspective.
And that brings us nicely where you describe that construction is not something that is mass production. And that perhaps makes my next question especially relevant. Your work in leading the project you're leading now does apply your engineering skills, but of course, it also requires others. So I was keen to ask you to talk about the range of skills that were needed to successfully manage your project.
Of course. So I would say that my engineering skills did form a very strong foundation of my capability to take on the challenges of this project. And mind you, there will continue to be challenges as we go down this path. But I think a strong training in the world of engineering did and will continue to pay dividends to you know, my capability to continue to problem solve. Because at the end of the day, there has never been, and you know, very smart people like the folks at Katerra have tried to come in and, you know, do something different and deliver better, you know, better quality homes and you know, using technology. and they have failed. So I would say that, and this is quoting one of my mentors at Mattamy. She told me once that, you know, technical colleges, they tend to teach you how to do, but university teaches you how to think. And I think that is extremely extremely true, and particularly with engineering, right? As an engineer, we're taught and repeatedly hammered the scientific process into our minds, right? Um, Everything that we do, every analysis, every problem that we take on, our focus is on identifying the problem with a list of givens. So what are we actually trying to solve? What are our constraints? Right? What are the physical limitations? What are the financial limitations? What are the, you know, whatever else is that may or may not hold us back? And also, here's a big one: to list our assumptions, right? Because we have to operate, and there will always be unknown unknowns, and you can never really tell all of it. So you just have to, in some cases, make an assumption and run with it. And then what you next do is you establish a hypothesis for whether you can solve it. You perform your tests on the hypothesis, you analyze what your results are, and you communicate the outcomes. So I'm describing by and large a scientific process, but if you think about it, this process isn't very different from when you, let's say, try to run a pilot project, which, I'll be honest, is a large part of what I've been trying to do within Mattamy in order to get this up and running. Clearly, walking in and you know, if I walked in and tried to talk my CEO into giving me all 4,000 homes to run a unproven methodology of you know, of 3D modeling of homes and so on and so forth, the first thing he would do is probably kick me out of his door. The next thing he would do is probably fire me. But, and put it this way, nor would I want to, because doing something like that, I can't do it alone. I need a team of technology partners and capable consultants that are willing to back the project. We need architects that are willing to use the information that comes out of the system. There's a whole ecosystem full of very, very smart folks that need to really come together in order for this to work the way we want it to work. And that both I guess energizes me, and sometimes it is quite daunting in the sense that you have to link up different personalities, different aligning folks with different interests in order to get this work done. And I think that takes me to the other piece of the skill set that is necessary, which is people skills. You know, and I say people skills instead of using the word soft skills, because I don't think there's anything soft about being able to, you know, deal with people and, you know, deal with competing personalities and so on and so forth. But however, having said that, perhaps the reason why it's called soft skills is because it's something that's very hard to pinpoint and very hard to train, as it's somewhat elusive on what is the exact right methodology to to go about doing certain things. So in a lot of those cases, I guess I will call this a skill, because I also know that this is something that is not common despite its name. But I would say the soft skills portion of it has a lot to do with common sense, which again is not common. But yeah, I would think that would hopefully round off the question of the key skills needed to manage such a program.
How did you get support for the project implementation? Was the order that you implemented the project influenced by this?
In this case, I think because of the unique situation of how I started on this, there were some implications of how the project had flowed. Or program, I should say. Because what happened was I joined about a year and a half into the start of the BIM program at Mattamy. I think I joined Mattamy itself at about the half-year or 1-year mark, but I really took on the managing role of this program 1.5 to 2 years into it. And because of that, the person who was previously running this, which is my now boss, the VP of architecture, had already established some pilot projects and was already moving, like there were already moving parts of how this was all coming together within the organization. So some of the existing pilots were inherited. Other pieces of it were very specifically and cautiously put together and launched. The idea was always that, and this might actually be interesting for those who are listening to understand, because in a lot of organizations, and mine included, we are innovative. I believe this, but having said that, it's very hard to understand how to innovate. And especially for me, I was somewhat new to the organization, and that, but honestly, the fact that I was there, which was through a leadership development program, in and of itself was an innovation, because Mattamy at that time was willing to take a chance on someone that was outside of the industry, myself, to come in and try to do things differently. So therefore, I felt like I had the onus was on me to push some boundaries, let's just say. And so therefore I chose to dive into this area, but I dove in cautiously, because number one is a question of funding. So I will quote one of my professors again from my Waterloo days, my mechanical design professor, who at the start of my final year, I think it was my 4B term, my very last term at Waterloo, he walked into our classroom and asked us, if I told you to design a rocket, could you? And the whole class remained silent for a minute or two. But when none of us answered him, he said, well, I asked you this rhetorically because you could. Now, the reason you could is if there were absolutely no constraints. And so if you didn't have to worry about money, if you didn't have to worry about timelines, if you didn't have to worry about throwing resources at it, could you do it? Absolutely, yes. Every single one of us at that point in time had enough background engineering knowledge and enough capability to build upon that knowledge, and grab resources and read existing documentation of how rockets were built to do so. But oftentimes we're limited, and actually not oftentimes, every time that we go about doing something in the real world, we will always be limited by financial constraints, by resource constraints, whether monetary or human resources, and there's plenty of those cases. And this is where the whole concept of like the scientific method of problem solving really does come about, because you have to list your constraints, remember. Now, our constraints, and I think for any upshoot of innovation, will always be financial and buy-in. So from my perspective, also from my boss's perspective at the time, the best way to launch is through small pilot projects that we can get together and roll them into different scenarios to test out if this particular method works. And on top of that, we're also testing whether our consultants are able to support what it is that we want to do. We're testing whether our internal processes are able to accommodate and adjust to the delivery of these new types of goods. And we're also evaluating whether the outputs are desirable, or the level of desirability of these outputs, which are, I believe, all very important conversations. And the reason, in a way, and a lot of people might ask, and perhaps especially folks like Katera, they would ask, why are you going so slowly and cautiously? Well, I think another analogy comes into play here, which is the idea of the Pandora's box, because it's very easy to get excited about available technology and then overpromise and underdeliver. And that would be the scenario of the Pandora's box, right? If we've tested, and while it's half baked, or maybe we tested 3 homes out of 4,000 homes, and those 3 homes worked out perfectly, we might say, like super excitedly to the world, that all right, we figured out this problem that is BIM and 3D technology, and we're ready to roll it out to the entire organization. The moment that button is pressed and Pandora's box opens, you can't just take it back. And at that point, if it all comes tumbling down, the amount of damage that it can do for such a promising program, if it did not work at that point, could be monumental. So if there was, if there was any rationale of why to go slow and steady, I would say that would be it.
Thank you. And in what you're doing, you're standardizing construction activity to an extent. Could you talk about how that was received by the construction workers and how you're managing that?
So funny story on that one, and it partially has to do with what I said about the Pandora's box, because despite going small scale, those and having the foresight essentially to see that this could be a possibility of happening, it still ended up happening a little bit for us. So because BIM is it's standardized construction activity, it's supposed to deliver information management capabilities and so on and so forth. So it's not a one-trick pony, so to say, but on the standardization of construction activity, on that side of things, what happened was this: we worked with the construction team to define, and one particular construction team, as I said, pilot project went small, and we defined a set of outputs that we would really like to see. And to qualify this, normally construction is done in our world using working drawings, so issued for construction drawing sets from the architect, and those drawings are absolutely fine. We've been building with that level of information for years and years and years. However, there's a lot of information on those drawings, and so because if you think about it, that set of drawings is used by a framer in the same way it is used by a mason, in the same way it is used by a concrete forming crew, in the same way it's used by a exterior trim contractor. And because of that, if you think about each of the trades, obviously there's some trades that might be able to overlap in their usage, but there's some critical trades that would have let's call it not necessarily a tough time, but that's a lot of information to parse through before they go into construction. And what happens normally is we send these drawings out to the foreman, and those foremen go in and they mark up as necessary, cross out what you don't need. Maybe sometimes some highlighters get popped out, sometimes some correction tape or whatever might get popped out. Scissors and glue sometimes get popped out as well when you're combining and gluing together options and so on and so forth. And what we wanted to do in managing that, or in supporting that, was to make things more simple, which is all within the capability of this many trick pony, let's call it. What we did was we created a specialty drawing set that we've deemed the framing cut sheets. So ultimately, that is for the specific purposes of the carpenters who will go in and frame the house. That way, they don't need to calculate or back calculate the measurements for drywall thickness. They don't, like, measurements are stud to stud, as opposed from the exterior of a wall, which would be the edge of a stud, to another edge of the stud plus drywall, right? it essentially gives data and information that was never available before, because we never modeled down to that detail. And it, it was something that we believe, and to this day we still believe this to be true, will give an edge to our framers as they go through and produce the homes. And the other thing is that it creates a level of expectation, right? If in the previous world, a plumber comes in and does something, and then an HVAC contractor comes in and can't run his duct where he was expecting to, well, he'll have to run the duct around it, and that creates scenarios where you have undesirable circumstances that you have to go in and what we call backframe, but essentially we have to create a box around some of these cases in order to accommodate for it. And as time goes on, and like one box out may cost a couple dollars in one house, but when you multiply that across 4,000, that ends up being a fair number. So long story short is that documentation plus the actually normally do, but is done in-house by our superintendents, our foundation builder specifically, which is marking up a foundation cut sheet. So that specific set is for the foundation crews. What we've done with this is, we put it together and we've handed it off to our trades to do testing. And in the sense of, them seeing it and thinking that it's useful and it's great, that worked out extremely well. What did not work out well was because it wasn't well refined enough, and our outputs had some mistakes on it at the end of the day, and that caused a loss of trust, which is, again, obviously undesirable for the same reasons that I talked about when we were talking about Pandora's box. But overall, our construction team sees the value in having this. Their ask from us is actually quite simple, is that if we can provide something that makes their life easier and their work more efficient, they will lap it up and they will use it. Absolutely. The moment that it creates additional work, additional confusion, and forces any setbacks to our production schedule, that's when it will have a very negative impact and won't allow us to continue down the path. And this is, again, that's why we highlighted Katera earlier on. I think understanding that piece and understanding the absolute, like how absolute that declaration is extremely important if anybody wants to come in and do innovative work in this industry, because you can't stop this well-oiled machine. And this well-oiled machine might not be, put it this way. It's if you think of a giant 18-wheeler truck and those engines, well, they might not be precise machined Ferrari engines, but if you want to keep them running, they're very powerful. They can tow a heck of a lot, and they will keep running and running and running with regular maintenance. And that's what I believe the traditional construction process is. And so if you bring in an innovation and you want to do something different, it better be good, and it better knock everybody's socks off.
And that is something which is, not just the case in construction, but would apply elsewhere. You want the technology has to work, and the people who are going to be using it need to gain a benefit from it or see a value in the change that you're trying to make. I'm also interested in how the physical environment influenced the project. construction sites can be harsh, especially at the time of year we're recording this in the winter.
Oh, yes.
So how did that affect what you did?
So that always, in my mind, it always factors, and this is interesting too, because uh, the idea of creating the cut sheets that I was just talking about, these are 2D printouts that are essentially simpler versions or more direct information to our site folks than they would get in a normal working drawing set. But if you think about it philosophically, what we're doing is we're taking a 3D model and we're still extracting 2D information in order to use it on site. A lot of and mind you, this was what used to happen in the old days when I was doing engineering in the EPCM firms as well. But the difference is that, well, nowadays a lot of people they ask me, well, what is BIM? What are you trying to provide? Well, the answer is yes, it is partially the 3D model, but there's an additional step to take that 3D model information and get it into a 2D printout, and that is what we're actually delivering. And so when I talk about a user experience, which sounds very tech-like and almost non-construction style, it is very true, right? Because it is a tech-based generation of an output, and that output is getting used on site. And when you like what you alluded to, the physical environment, I will give you a little bit of an example of how it, how things looked like to me the last time I was on site. So I was walking down the site. This was last winter, or I think last year, or this year, I guess, earlier in January, end of January 2021. I was walking the site, and what I saw was on the rafters there was a framer who was there to. I believe there was some damage that might have been that there might have been for one of the trusses at the very top, and he was there to mend it. But it was extremely impressive because my hands were frozen, but I was looking up and I could see his breath, like him breathing out, and all the all the fog, or whatever you want to call that, as he was working. And what he was doing was he was expertly fitting a piece in between where it had broken off, and I think he probably cut it exactly to length, and like it looked perfect. It was amazing craftsmanship, but he was doing this in negative 20-ish Celsius weather plus wind chill. It might have been negative 30 or 40. And so when I always think when we do our BIM outputs to that gentleman that I saw up there, because it's under those conditions that they're reading this document. So if there's anything that is unclear, or if there's anything that is not not matching what their expectation is, and I'll call those errors, right? What if there's anything that looks suspicious, or if they had the working drawing set and they compared it to this, it didn't match. Well, they would have a really, really hard time trusting that output. And so that's what I mean when I think when I talk about the user experience, because when you think in their shoes about what they're going through and how and what conditions they're using the information that you're providing, as a whether it's innovative technology, or even if you're just drafting a regular old working drawing as an architect, that goes a long way with providing the right solution, I believe. And I always keep that mindset close close to my heart, because I think at the end of the day, what we can accomplish largely has to do with our trades and the success of our site teams, because they're the ones who are right out there in the trenches, literally, putting the homes that we produce together and getting them into the hands of our customers and our homeowners. And that's where the rubber meets the road. And if we are to be successful in doing any sort of endeavor, including and probably specifically if we're doing innovation, those folks need to be supported and their needs need to be met.
We're experiencing a shortage of workers at the moment. Does the project help deal with that?
Well, that's certainly the hope, Peter. When I think about what we can use to bring to the table, and that includes the 3D model that I was talking about as well, right? So in the past, if you got a worker to look at, and even right now, right, as the shortage is happening, but still we have a lot of experienced workers that are on site. And it always blows my mind because you give them an architectural drawing which gives them the front view, the side views, the top view, and plan views of our designs. They have it in their head, and they I think someone described it to me as if they're seeing sort of like the Marvel world or Iron Man's world of the 3D VR or AR setup that they can sort of see, but they just visualize it in their heads. When they look at a plot of land, they can already see the final built home. That's how someone on site have once described this to me, and I thought that was amazing. But at the same time, folks like that are becoming fewer and further in between. So what I'm hoping with this program, and in a way, that's why this is perhaps innovative. And it's the idea of this whole program is that right now it might not be that extreme of a necessity because we have those very skilled, very powerful craftsmanship folks that are on site that can deliver amazing things with very little or just enough information. There will come a time where that skill set drops off, and we might have to rely on either lower skilled tradesmen, or in some cases maybe even a lack of trades to support us. And so when that happens, well, what can we then fall back on? Well, perhaps it's panelization. Perhaps it's factory built homes. Perhaps it's what I like to call Legotization or IKEAtization of our plans, where it's made simple enough that you don't need a highly skilled trade to come in and be able to do it. Or maybe it's all of those things, right? And while I don't know which one it might be, I believe setting the roots for this program is a start for accomplishing all of those ideas. Because if you have a 3D model, well, it's an easier proposition to take that information and send it to a panelization company for their saws to automatically cut them out if you already have the lumber and the studs and the plates and all that stuff modeled in. If you have the model, it's also easier for you to, if you were to set I guess this is what we called 4D BIM or sequencing of construction. If you know what has to go in first and what has to go in afterwards, it becomes a lot easier to create that Lego or IKEA style instruction set for our, or depending on how technology develops, maybe it becomes a augmented reality goggle that tells them step by step what to do, or it might become something, or it might just be the same thing as a IKEA instruction set where it's like where you label step 1, 2, 3, 4 in a clear and concise manner. I don't exactly know how that's going to come together, but would that be easier to be done if we had a 3D model with like smart detailed information within it versus a 2D CAD drawing? You betcha. So yeah, I think that's a very and for me, it's a medium to long term outlook for why we're doing this. And in a lot of cases, it's hard to convince folks to see that far away. And while I like living in this world, it is somewhat ambiguous. And that, I think, if I were to answer or hop back to one of the earlier questions about key skills of, how to run something like this, and I think I would have to add capability to handle ambiguity is a big part of it too, because most of what I'm trying to do hasn't been done before, and I think I said that already. But in order to figure out what to do, that is like, no one's going to give me a step-by-step instruction set on how that's going to happen. What I'm trying to do is build that step-by-step instruction set, funny enough. But yeah, that would be another key skill, I'd say.
Interesting and fascinating to think of what the technology might be able to do in the future. I just wanted to ask you one final question, which is any further advice that you might have for engineers who would be watching this?
So I think that I can say that, well, number one, and I think I said that earlier on as well, which is my engineering career and my time as an engineer had a lot to do with what I am doing right now, and like the problem solving skill sets that I've learned, the method of thinking that I have learned as an engineer plays a huge amount into the why and the how of what I'm doing right now. And I would also say to those engineers who are who want to dive into a different, how should I say it, if they don't necessarily just want to do technical work, which is why I left the pure engineering world, and I am currently non-practicing, just so all the engineers listening to this understand. But in order to get in, like, going into the business world didn't necessarily mean that I dropped the key piece of what I felt was important of being an engineer, which is the problem solving. I'm still trying to problem solve. I'm still trying to do something that is an innovative piece of technology, which is it's interesting. Some of my friends keep teasing me that I never really truly left engineering, and they're not wrong. But like on a very exact and technical basis, I am currently non-practicing. And so in that case, I mean, I would say that if you're wherever you are in your career as an engineer or not as an engineer, you know, go back to your training, go back to what it is that you know, and go back to that problem solving mentality and mindset, because that can pay dividends hugely no matter what industry you're in. If you go into finance, if you stay in technical engineering and build pumps and compressors, or if you're in a role like mine trying to wade through ambiguity and deliver innovation.
Very, very good advice, and a good note to end on. Thank you for your time, Derek. I really appreciate you talking to the people who'll be watching this, and what you've had to say, I think, has a lot of value for them. Thank you.
And Peter, as I said, the honor is all mine for being here today. So thank you for having me.